I can just edit the video. All right, so now we're going to talk about factoring trinomials. Yeah, sorry. That's what we have whiteout for. Okay, factoring. Shh. Factoring trinomials. All right. Now, when I say trinomials, I'm talking about in the form of ax squared plus bx plus c. Okay? And when we factor these, so we're going to factor the lead term, x squared, and then find the factors of c that have a sum of b. And when I'm talking about c and b, I'm referring to this up here. All right. So, for example, okay, this is what we've been working towards all month so far. Let's say I have x squared plus 17x plus 60. If you were to factor this polynomial, or this trinomial, kind of the same thing as I told you guys before at the beginning of the year, polynomial, as long as it has more than one, it's poly, right? Okay? So, you've got 17 and 60. The column on the left is the adding column. The column on the right is the multiplication column. We want to get all the terms that multiply together, give me 60, and then add them on the other side to see if we can get 17. So for 60, we've got 4 times 15. We've got 3 times 20. We've got 2 times 30, 5 times 12, and 6 times 10. We'll stop there. If we add them together the other side, so we add these, right? We get 19, we get 23, add these two, we get 32, add these two, we get 17. There's the pairing I want. So that means my answer is going to be x plus 5 and x plus 12. And that's it. Okay? Now, a trinomial is basically a binomial times a binomial. We know that. Okay, basically what that means. That's basically what we're talking about here. The question, however, I want you to ask yourselves is this. I wonder if one or both of the binomials will factor for m to the fourth minus 7m squared minus 18. Now, don't freak out. Because I know what you're thinking. Wait, that's not an m squared or an x squared, or there's not a square in the leading term. Oh my God. Relax. You can still break it apart. Okay? So what you're going to do is you're going to take m to the fourth and you're going to split it. So that it becomes m squared times m squared. Okay? Now you can work with that. You'll have m squared something times m squared something. Meaning that we're coming from the fact that m to the fourth plus 7m, sorry, not plus, minus. Minus 7m squared minus 18. Okay, take the t-chart. Move it up a little bit. So we need to find two terms to give me -7 and -18. Notice the negatives go with it. That holds true also for the box method as well when you're factoring there. The negatives will stick with their partners. Plus sign, nobody cares. Okay? So we have 2 times 9. We have 3 times 6. We have 1 times 18. One of these has to be negative because we need -18. We want the term also to be negative in the middle. We want the larger multiple of the two multiples, the larger number, to be always negative then, so we can guarantee we will get the negative number in the middle. It means -9, -6, and -18. If we add those numbers together, we should get -7. Well, look, there it is right off the bat. So that means we have -9 and we have +2. Now, the question is, can we factor again? Because now we have a square involved. Okay? Note something. Okay? Note, m squared minus 9 is actually factorable. As a perfect square. Now, when you hear the perfect square, this is what you should think of. A perfect square is possible when you multiply a integer hyphen or variable hyphen times itself. The resulting product is called a perfect square. Okay? So what that means is that we can take this guy and basically do the box method, or technically we can't use box method. We can basically do the square here, like we did here, all over again. Now, what I recommend you do is I recommend you actually add a placeholder in the middle. Like so. 1, this will prevent any errors and misunderstandings. 2, this will allow you to better visualize what's going on in the middle. Okay? Which is basically, this is equivalent to m squared minus 9. Just means this is basically go to 0. It doesn't exist. We're good. Okay? So let's break out the t-chart. We need two terms that add together to give me 0 and multiply together to give me -9. Really, there's only two options. 1 times 9 and 3 times 3. We need to make this one negative, and these are the pairings we need, because 3 plus -3 gives me 0. So that means that this guy can factor to m minus 3 and m plus 3. Now, fun little fact here, there's a shortcut. Pink. If you take the m squared and the 9 and take the radical of each, you will get the same thing. What is the radical of m squared? Well, it's m times m, so it's just going to give me m. And the radical of 9 is 3, plus or minus 3. That's why there's two of them. Does that make sense? There are 2 zeros with every single square, meaning the fact that I can plug in a -3 or a +3. Why? Because when I plug them in, I'm going to get 0 back out regardless. This right here is so fundamentally important because when we have perfect squares, they are gimme problems. You can literally look at them and you know the answer. Literally look at the last term, take the square of it, done. That's your answer. If you need to do it out, that's how you do it out. But realistically, you should see you shouldn't have to really do that. So, therefore, my final answer will be m minus 3, m plus 3, and m squared plus 2. Notice that if the middle term is positive, you cannot factor it. It has to be negative in order for there to be a perfect square. If you remember back to the worksheet we did, it basically showed you that when we did all those examples, okay? All right.